Hello everyone, welcome to today's movie. In today's movie we'll take a short time series and we're going to fit a trend line to that data and we're going to fit a prediction interval, and in this movie we'll use Excel. In another movie later on we'll use SPSS to solve exactly the same problem. So if we go to Excel solution, you will see that we have some data, and the data is 15 years of the average annual UK unleaded petrol prices in pence per litre between 2006 and 2020. So you'll see that in 2006, which is time point 1, the average annual unleaded petrol price was 88.9 pence per litre, but in 2020, which is time point 15, it was 119.9 pence per litre. So what we want to do first is fit a trend line. Now, in this particular movie, rather than calculating the regression coefficients from regression analysis B0 and B1 and then using that to calculate the trend values, you can actually use the Excel function trend, as you can see there. So you can see there that we have the range for Y, the known Y values, the range for X, the known X values, and then we have the first values at B4. Notice that I fixed the range C4 to C18. Look, C4 to C18 and B4 to B18 because that's the original data. And the first value we want to calculate for the trend is when X is equal to 1, which is in cell B4. Now what you can do now is you can drag that data down to there. Okay, so you can see that a trend line fit to this data using least squares regression method. At time point 1, the trend line would be 100.74. The actual data value is 8.9. Time point 15, the trend value is 126.43, and the actual data value is 119.9. Now what we can do now is, if we wanted to extend, so we wanted to use this trend line here to predict for time point 16, 17, 18, 19 and 20, i.e. forecast into the future, then we can just drag down that trend line. So we can see that the forecast for time point 16, which is 2021, would be 128.26 pence per litre, and at time point 20, which is 1, 2, 3, 4, 5 years into the future, it'd be 135.6 pence per litre. Okay, now what we want to do now is we want to fit a prediction interval to this data. But before we do that, let's create the scatter plot. So what we want to do is, if I highlight that data and then copy, and then what we can do is insert, and we want a line graphs, let's choose that. So that's how the series varies with time. So I just increase the scale. There we are. Okay, so we can sort out the chart title. The vertical axis is the series value and the horizontal axis is time point. Now what we can do now is we could also plot the trend line to that data. So if I copy that, click anywhere inside, right click and then paste. And there's your trend line. And again, you can fit labels for these lines later on. So you can see how the trend line is, and you can see we're extrapolating into the future, which therefore is these values here. Now what you can do now is you can fit a prediction interval for each time point X. So we could say, let's say we want a 95% confidence interval, which represents a 5% level of significance, and therefore based on each X value, we can say, what would our prediction interval be for that to be 95% confidence for each value of X. So we have an upper prediction interval and we have a lower prediction interval. And what we do is we have to use these equations. There's your prediction interval there. We need to know what the T critical value is for 5% significance. We have 13 degrees of freedom because remember it's n-2. Because we've got least squares regression. Okay, and we only got one predictor variable. So from that, we can use t.inv.2t to calculate the t value, which is our critical value. We also need, if you look here, we also need to know what the standard error is, which is this term here. Look, there it is. SE subscript Y at comma Y, which is that number there. And we can get that number using Excel function STEYX. The Y range, which is C4 to C18, C4 to C18, and the X range, which is B4 to B18. If we substitute all the numbers in, we find that this term here is given in column E, and then all we have to do is drag down. Now we can drag to there, or we can drag all the way down to include the fit for the actual forecasts. So this bit here is the regression line fit to the actual data series time points, and this is the forecast bit for the forecast time periods. And then once we've done that, then we can use this equation to tell us what the upper and lower prediction intervals are. And as you can see here, the prediction interval in the positive direction is Y at plus E. So in there, we should have D4 plus J5, which is SE, times the T value, which is in J5. So you substitute those numbers in, and then you can drag down. Remember, if you look at the equations, you'll see that I've fixed J5 cell reference there, so it doesn't change. And then the lower prediction interval is this part here. So it's the trend value minus the error. So as you can see, look, there we are. So there's a trend value, and then this is the error. And again, I've fixed J5, so I can copy down. So there we are. So you can see here that you've got the trend line. So x equal to 1, the actual series value is 88.9. That's what was observed. The trend line fit would give us 100.74. The 95% prediction interval for that value of x, based on this trend value, is 65.26 to 136.21. Now what you can do now, of course, is if I copy that on, I can copy those lines onto the graph. So there's the upper, and then if I do the same again, copy, and then click on the graph, and then paste. So there's the lower, etc. So you can see how the distances there changes with time. Can you see that? Yeah. So there's your original series. There's the trend line fit, and this is your 95% confidence for that prediction interval from the low p-value, prediction interval value, to the upper prediction interval value. Okay. So in the next movie, now obviously you can sort out all the labels, but in the next movie we'll look at how we solve this problem using SPSS. So bye for now.